you know what? All right, so on worksheet 4B, we have the patterns up here. This is a short leg of a 30, 60, 90, so we need to double it to get the hypotenuse, which would be which letter on this picture? The X is the hypotenuse, and if we double 19 halves, we just get 19. Everybody okay? And then the long leg across from the 60 is supposed to be the short leg times the square root of 3. And what is the short leg on this picture? This 19 halves. So when we do 19 halves times the square root of 3, you can just put it on top, or you can write it behind it. Doesn't matter. All right. We haven't talked about this pattern yet today. Remember this pattern? When you have a 45, 45, 90, you have two equal legs and then a leg times the square root of 2. Luckily, they give us one of the legs as a plain old 4. So what is V over here, guys? 4. And the U up here, the hypotenuse is... Okay. I'm going to tell you that these look like this on the quiz, and then there's blanks down here that say U and V. I would just label them on here first because it's easy to get them backwards when you write them in the blanks. You know what I'm saying? Draw it on the picture first. All right, if this is 14 square roots of 2 and we have that pattern again, then each of these is just what? 14. Now we're back to the 30, 60, 90. So we have x, x square roots of 3, and 2x. So if this is 11, I feel like we did this one already today. What do we do to get down to this guy? We have to cut it in half, so this would be 11 over 2, or 5.5. And then what do we do to get to the long leg? You take the short leg times the square root of 3, so we end up with 11 over 2 square roots of 3. All right, I'm going to give you... Maybe I'm not going to give you anything. Yuck. Let's do a couple more together. Let's skip 15. It's really the same idea as 16 here, I think. If this is a 45, 45, 90, the legs are both the same, right? So I'll write this one in quick. It will be 17 square roots of 2 over 2. What would this one be on 16? 10 square roots of 2. And then what is the pattern? If you have x, x to get the hypotenuse, you have to multiply by square root of 2. So we need to take this mess. Oh, come on, pen. And multiply it by another square root of 2. What's that going to become, guys? Square root of 2 times square root of 2 is 2. So 10 times 2 makes this a... Now, this is hard for our brains to wrap around because the square root of 2 is supposed to be on the hypotenuse, right? The problem is it's in disguise, okay? It's multiplied inside of that number. So this one would be 17 square roots of 2 over 2 times another square root of 2. The square root of 2 times square root of 2 would become 2. And then that would divide the 2 on the bottom, so this would just be a 17. That's really ugly. All right, this is supposed to be our warm-up, so let's do 18 first. 18 is the easier one. Across the pattern for this, again, if this is the short leg, the hypotenuse, that's a 2, sorry, and this is x square roots of 3. So this has 7 square roots of 3 where it's supposed to have a square root of 3. So if we take off the square root of 3, where does the 7 go? V, and the u would be a 14. All right, this one is going to be ugly. Does everybody agree? Because it's supposed to have a square root of 3 there and it doesn't. So 15 is really the short leg, which I'll call x. You could call it b on this picture, times the square root of 3. What do we have to do to solve that? Okay, 15 gets divided by the square root of 3, which means we need to multiply top and bottom by square root of 3, which gives us 15 square roots of 3 over 3. Does that reduce? The 15 and 3 can reduce to 5 square roots of 3. All right, where does that go on our picture again? Okay, 5 square roots of 3. And then what do you do once you have the short leg to get to the hypotenuse? Just double it. So what is that going to be if I multiply it by 2? 10 square roots of 3. Everybody okay? All right. Who's got 19 quick? N is 19 and M is 19 square roots of 2. Okay. Number 20. All right, our pattern here should have a square root of 3 times x. Can we divide that by a square root of 3? It's easier than you think. Square root of 15 divided by square root of 3. They're both on the same, so they're both underneath a radical, so it becomes a what? Square root of 5. So where does that go, though, on this picture? That's the short leg, the square root of 5. And then you have to double the short leg to get the hypotenuse. So what is the square root of 5 doubled? 2 square roots of 5. Doesn't matter how slow I write, this thing still doesn't want to work right. All right. We are going to switch back over to today's lesson, which is on, okay, so it's the next page, I think. We're going to do some application problems. But first of all, the learning targets today are setting up the right triangle trig applications and solving, and then finding the 6 trig functions. So we're going to learn about the reciprocals today. All right. So before we get too far, the steps to solving application problems are to draw the picture. It should have a right triangle for all of these. Label the parts that they tell us, including your right angle, and then decide, is it sine, because we have an opposite and a hypotenuse, cosine, because we have an adjacent and hypotenuse. Remember, this is long A, short A to help us remember those. And then TOA, if we have a tangent and an opposite and adjacent, sorry. And when do we use that second button on our calculator? If we're trying to find an angle, right? Then we would do that whole, like, maybe sine opposite over hypotenuse, and we type that in, and that'll give us an angle. Okay. Now, one more thing before we actually start the problems. You need to understand the vocabulary of angle of elevation and angle of depression. Okay? Angle of elevation is, if this was a cliff or a building, let's call it a building, it looks more like a building. Angle of elevation means you're standing far away and you're looking up, okay? Angle of elevation is down here. Angle of depression is if you were standing on top of the building up here, here's your smiley face, and you're going to look down to that same spot. The trick is that the angle of depression, okay, is still from the horizontal line. It's not from the building out. Both of these, angle of elevation and depression, are from horizontal lines. Horizontal meaning going with the horizon this way, okay? You will notice that they're parallel then. I don't know if you remember that little symbol from geometry. But that makes these angles in here what we call alternate interior angles. Does that sound familiar? That they're the same, okay? But this angle is not, okay? This angle in here is not an angle of depression or an angle of elevation, okay? and it's not equal to those two. And that's the mistake students make very regularly. All right, I happen to give you a picture on this one, but a lot of times I would give you this information without a picture. So you would say angle of elevation if you're standing 400 feet away from a building. So you'd say, okay, I'm 400 feet away. Building means there's a 90 because they're mostly straight, unless it's a leaning tower of Pisa. And the angle of elevation means I'm standing there looking up. And this particular question says the building is 850 feet tall. You don't have to draw a picture. It already had one. I'm just trying to talk through it as though it didn't. To find an angle, can you tell me what these are called? Can I do the OAH thing? Where are we going? From this angle, this one is opposite. This is the hypotenuse. This is adjacent. I know nothing about the hypotenuse. The function that uses O and A is tangent. So I can write the tangent of the angle, which I don't know, so I'm just going to write theta, equals, be careful, it's O over A, so it's 850 over 400. And I don't care if you write this down or not, but this is how you type it in the calculator to work backwards. Maybe it would help some of you to write it down. But on a quiz, you can write one or the other of these. You don't have to write them both to show your work. We do second tangent, 850 over, I forgot, 400. And I got 64.8 if I round to the nearest tenth. Anybody else? Again, the quiz says round to the nearest tenth, so that's what I'm going with. Questions? Okay, I drew a picture here, or I put a picture on here, but again, it just says there's a tower, the angle of depression. Okay, so now you're standing up at the top of the tower, looking down towards some stake that's in the ground holding the tower up, okay? The angle of depression is 60 degrees. Someone's going to put that in here. But remember, angle of depression is from the horizontal looking down. So that's 60, which means the angle of elevation out here is also 60. The top of the tower is 80 feet above the ground, so our straight leg over here is 80 feet. Okay, what function are we going to use? What are we trying to find? I guess that's, how far is the stake from the foot of the tower? Everybody okay with this being the X then? How far is the stake away from the foot of the tower means the bottom of the tower? I think we got tangent again, don't we? This would be opposite. This would be adjacent. This would be hypotenuse, but we don't know anything about that. So I think we have tangent. But this time it's tangent of what? 60 degrees equals 80 over X. Now, this is a 30, 60, 90 triangle, which is totally drawn inaccurately, right, guys? This shape, this should be a 30 according to the way I've drawn it. It's badly done. But we want a decimal. We don't have to use that special pattern. We're just going to use our calculator. When we cross multiply here, we get X times the tangent of 60. And again, if you don't write this step out, that's all fine with me. And 80 times 1 going that way. So we end up having to type in our calculator 80 divided by the tangent of 60. And I don't usually show that much work, but that's a 60. Oh my goodness. $80 divided by the tangent of 60 I got 46.2. Anybody else? Label on this one? Feet, right? All right, I need to try to go a little quicker here. When you have a ladder against a house question, you need to understand that the house makes the 90 and the ladder is leaning, okay? My picture's horrible. Again, the angle is not good, but it says it makes a 30-degree angle with the ground. Actually, it's not that bad. So the ground here, we're assuming level ground, okay, makes a 30. The foot of the ladder is 7 feet away from the house. So they give us 7 feet is from the bottom of the ladder to the house. Everybody would put that in the right spot. How long is the ladder? So where's the X going? Yes, on the hypotenuse. Okay? Because this is our ladder leaning here. All right. So from this angle, again, we have a 30, 60, 90, but a decimal is fine. We don't need to use our special right triangles. I will tell you when you need an exact answer. So this is adjacent and hypotenuse. Which function is that, guys? Cosine. So we have the cosine of 30 equals 7 over x. So again, we're going to need to divide. 7 times 1 is 7. And then we need to divide by the cosine of 30. These notes are messy because my pen isn't working right. It worked fine in the other classroom, though I'm thinking it has something to do with this smartboard. Is that what I'm supposed to type, guys? 7 cosine of 30? 8.1? All right. I don't know why people have struggles with these shadow questions. I found a little picture here to show you, but guys, the shadow's always on the ground, okay? I have people who measure the shadow like is the hypotenuse. Well, if you have a tree and it's shadow and you're going to measure the shadow has to be laying on the ground. You can't throw the tape measure through thin air to measure the shadow, okay? If we measured the shadow is 21 meters. The angle of elevation of the sun, well, if the shadow's over here, it means the sun was over here somewhere, right? And when we were standing at the end of the shadow to look up here is where the 51 degrees was. Does that seem okay to everybody? Would you have figured out where the angle of elevation went? Remember, elevation is always from the horizontal looking up. And we're trying to figure out the height of the tree. So we have an opposite, an adjacent. We're doing a tangent again. Can someone type this quick so we don't have to take a lot of time? We're multiplying this time, right? So 21 times the tangent of 51. One more time. Oh my gosh. I hope you can see my pen doing things that are not showing up right because I feel like I'm kindergarten writing here. Everybody okay? Yes, it's supposed to be a 25.9. All right. Those are my application examples. Now we have really, really important stuff to talk about yet. And I know we're a lot of time here. You guys switch back to this class? Okay. There's a packet over there by the wall. We need to memorize the functions and their reciprocals. So yesterday we did sine equals opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now, please listen as I try to help you understand how to memorize the reciprocal functions, okay? The reciprocal function for sine doesn't have an S at the beginning. It has a C. It's cosecant is the word, spelled out here, cosecant, which then flips this over, so it's hypotenuse over opposite. Okay, in the same way, if cosine had a C, it doesn't start with a C when you flip it over. It starts with an S. It is secant. And then it would be, there should be an angle symbol in there, but this pen is making me crazy. It would be flipped over, sorry, so it's hypotenuse over adjacent. And then the one that at least sounds right, tangent, flips over and becomes cotangent, okay? So it does have another C, but hopefully you can remember tangent and cotangent go together. This function, the co-function, actually means complement, and that's why sine and cosine go together, because if you were having a complement of the 60, the cosine of 60 is equal to the sine of 30. They're complements that way, but it's a different thing than the reciprocal function. So cotangent is going to be adjacent over opposite. Is there anybody in here who has not heard those terms before? Secant, cosecant, cotangent? Have you at least had a little exposure to those? Okay. That's hopefully how you can help memorize them. Was that enough of a tips and tricks, what I gave already? Okay. This is a really disgusting example at the top of the next page, I think. Is it the top of the next page? Okay. So I'm going to go quickly through it, but what they did is they had to use Pythagorean theorem to find the hypotenuse. And they got square root of 230, so they did 15 squared plus 3 squared equals hypotenuse squared. They simplified all that and they got down to square root of 234. 9 went in there and it became 3 square roots of 26. Blech. So this side was 3 square roots of 26. Okay, from their picture, with theta up here, this was opposite, this was adjacent, and this was hypotenuse. So then they went through and found all of these functions. And when the radical wound up in the denominator, they had to multiply to get rid of it in the denominator, okay? I'm not going to go through all these because we're going to do the next example together. And I think this one doesn't have a radical, and then we'll do one that does. All right, so if we're trying to find this missing leg over here, how does Pythagorean theorem go? Anybody tell me what worksheet this is? Is it 6B? 5B? Okay, do you find it, Antoine? Okay, so we have to do Pythagorean theorem. Where are the legs on this picture? The x and the 8 are the legs, everybody agreeing? So we have an x squared plus an 8, oh my goodness, squared equals a hypotenuse of 10 squared. So how are we going to type that in our calculator? Type 10 squared minus 8 squared. Okay. 10 squared minus 8 squared. 10 squared minus 8 squared. Please get used to using the squared button over here, not the to the second power. That's a waste of time. Okay, I got 36, and then I would need to square root that, which would just be 6. Everybody okay? A Pythagorean triple, I will use that word occasionally. Pythagorean triple means 3 nice numbers that work in Pythagorean in Pythagorean theorem, okay? Like 3, 4, 5, 6, 8, 10, 5, 12, 13. Those are all nice Pythagorean theorem numbers. A lot of numbers aren't, but we will use nice ones a lot of times just to make things easier. All right, then we need to do all 6 functions quickly. This is our angle up here on this picture. So this is an adjacent leg, an opposite leg and a hypotenuse. So we're going to start with sine, and then cosine, and then tangent. So the sine of theta is equal to, opposite over hypotenuse would be 6 over 10, which would reduce to what? 3 over 5. Then cosine of the angle, by definition, is adjacent over hypotenuse, which would be 8 over 10, or 4/5. And tangent, by definition, is O over A, opposite over adjacent, which would be 6 over 8, or 3/4. Okay, who can tell me the reciprocal functions? What does sine flip over and become? What did we just discuss? It changes to a C word, right? It's cosecant. And then we're flipping it, so it's 5/3. And cosine flips over to an S word, which is secant. And that would be 5/4. And tangent goes with cotangent, which is abbreviated COT, and that would become 4/3. We okay? You can do a messy one? I'm guessing the next one's messy. All right, if we have a 5 and a 10, when we do Pythagorean theorem, we get 10 squared. These are both legs, right? Plus 5 squared equals the hypotenuse squared. This is 125. If we square root 125, what's going to go in there that's a perfect square, guys? $25 goes into 125 how many times? Okay. So the square root of 25 times the square root of 5 reduces to what? Square root of 25 is 5. Square root of 5 stays square root of 5. So I have a lovely 5 square roots of 5. Okay, our little smiley face is down here this time. All right, if I write as slowly as my pen makes me go, sine, cosine, tangent. And some of you need SOHCAHTOA to help you remember what those mean. On this picture, if we're down here, this is the opposite leg, this is the adjacent leg, and this is the hypotenuse. So the sine should be opposite over hypotenuse, which would be 10 over 5 square roots of 5. Oh, I told you these are ugly. What do we have to multiply to get rid of that radical in the denominator? Square root of 5 over square root of 5. What else can we do? What can happen with this 10 and 5 that were out here? That'll reduce to a 2. And what's down here? Square root of 5 times square root of 5 becomes 5. So it is a disgusting 2 square roots of 5 over 5. Okay. You want to do the reciprocal while we're at it? What's the reciprocal of sine? Cosecant. Okay, I don't have room. Can I move this? This was the hypotenuse. All right. When I flip this original one over, If I flip this over, I have to rationalize it all over again. It's a big pain in the neck. What is the definition of cosecant? Instead of opposite over hypotenuse, it is hypotenuse over opposite. So it's easier to just write 5 square roots of 5 over 10. And what does that reduce to? Square root of 5 over 2. All right. Is this one any better? I doubt it. Cosine is adjacent over hypotenuse, so it's 5 over 5 square roots of 5. These 5s can divide out, and we just get 1 over the square root of 5. Eventually, I think you'll get good at doing this, so you won't have to spend a lot of time thinking about it, but if you multiply by square root of 5 over 5, you get square root of 5 over what? I said that wrong. You're multiplying by square root of 5 over square root of 5. 1 times square root of 5 is square root of 5, but square root of 5 times square root of 5 is 5. Okay. It is easier to flip it over before you rationalized it, so the secant, flip it over back here, okay? Or flip it over by doing hypotenuse over adjacent. What is hypotenuse over adjacent? 5 square roots of 5 over adjacent, which is 5. That's just going to divide out and be plain old square root of 5. Oh, praise the Lord, we get an easy one. Tangent is opposite over adjacent, which is 10 over 5 is 2. What is the cotangent then? We flip 2 over, and we get 1/2. All right. How much time do we have? None? We have 4 minutes still? Okay, we can do one of these. Is one easier than the other? Nope, they're both ugly. All right, all you're doing here is you're drawing a triangle and labeling what we already know. So draw a right triangle and put theta wherever you want. And then what is this telling us? Sine is opposite over hypotenuse. Everybody okay with that? So I need to, on my picture now, label the opposite as 3 and the hypotenuse as 7. Then what do I have to do to find the other one? Yeah, Pythagorean theorem would be x squared is one leg, plus 3 squared is the other leg, is the hypotenuse 7 squared. We're going to subtract a 3 squared. Ugh. Yep, it is 40. So x is the square root of 40, or square root of 4 times square root of 10, and I have to use 4 because 4 is a perfect square. So I get 2 square roots of 10. And this was a 7 over here. Okay. So from our angle, opposite, adjacent, hypotenuse. All right, I'm going to try to go quick. The sine is opposite over hypotenuse, 3/7. So what's the reciprocal of that, guys? Okay, and which function is 7 over 3 then? Cosecant. Okay, I can't write at all now. Cosecant. And that's a 3. All right, cosine is adjacent over hypotenuse, which would be 2 square roots of 10 over 7. Flipping that over will make it secant, but that's going to be kind of miserable, right? We get 7 over 2 square roots of 10, and what do we have to multiply by? Square root of 10 over square root of 10. So it will become 7 square roots of 10 over 20. 20. Yep, can't read that. All right. Are the other ones gross too? Yes. Tangent would be 3 over 2 square roots of 10, which will become 3 square roots of 10 over 20. And cotangent, if we flipped it over back here, it would have been 2 square roots of 10 over 3. All right. So the homework tonight is twofold, guys, threefold for some of you. You need to go back and make sure you finish the first delta math, if you didn't yesterday. On worksheet 6A, you need to do 4, 6, 7, and 8. Can you circle those now? 4, 6, 7, and 8? At least. You can do more for extra practice. And then there's also a little delta math called basic trig ratios in quadrant 1. No.